Welcome to our program, Astronomy for Everyone. My name is Don Glazer, and I'm your host. In our last show, we talked about observing with only using your eyes, no optical equipment whatsoever. This month, we're going to change up, and we're going to go to binocular observing. With me today are two members from the Ford Amateur Astronomy Club. To my left is Ken Anderson, and next to him is Steve Woody. So Ken, we've got quite a range of binoculars here on the table. Why do we have so many?
Well, most of these binoculars on the table are my personal binoculars, and we have a variety of binoculars because they cover both the wide field of view, low power, and the high power, narrower field of view.
All right, but why would a person want to have binoculars? What benefit would they give a person over just using their eyes?
Well, you can see a lot more with binoculars, any binoculars, over your naked eye. And I do a lot of observing with a telescope, and I do use some binoculars, like this one is my favorite one to use. And I can see the dimmer stars, and then it helps me point to the correct object with my manual telescopes.
I see. Well, if we're going to start at this end of the table, please tell our viewers why they would want to start with that particular type of binoculars.
Okay. Well, I'll start with the widest and work my way up to the highest power. So these binoculars are 2.3 power times 40 millimeter. That's the aperture in the front. And these give a 28-degree field of view. These are called binoculars or opera glasses. And with these, you can see almost entire constellations, or entire constellations if they're small enough. And the Milky Way looks very awesome in these type of binoculars. And
right, the Milky Way is the galaxy that we live in. And the Milky Way is called the Milky Way because it looks something like you've got a swath of milk going across the sky. In fact, the word galaxy comes also from the ancient Greek word for milk. So the Milky Way and our galaxy are named after milk, and so all galaxies, in some sense, are named after milk.
Very interesting.
Thanks very much, Steve. So with these, in addition to looking at the Milky Way, and you can pan across on the Milky Way and see the whole sky, just pan from horizon to horizon. It looks awesome, and you can see a lot of objects in the sky, in the Milky Way, with these binoculars panning. And also, like looking at Orion, you can see the whole bottom half of Orion with the sword in the center. And if you looked at Andromeda, you can see those star-hopping stars that you normally would need to do mentally in your head to find it in a telescope. So
tell me, Ken, you said star hopping. How can you hop on stars when they're so far away? What does that term mean?
Well, star hopping means going mentally from one star to the next star to find your object. So you could be going from known objects or known stars or brighter stars to dimmer stars. But like when I find Andromeda, I'm basically hopping between two stars and finding my way to where I should be pointing the telescope.
So in other words, you're using them as a guidepost to lead you to something else.
As a guidepost. And with these, you can see all those guideposts all in the same field of view, which you don't have the luxury of in a telescope.
Very interesting. Well, what about some of these other ones here on the table?
Sure. All these wide-angle ones are really great also for like watching your kids in sporting events or shows because they show a whole lot of the stage or the field, and it's very easy to keep them in the field of view. These are 7 by 32, 14-degree field of view, so it's half the field of view. But with these, you can look at in Taurus, you can see the Hyades and the Pleiades really good. It's about 2 fields of view, whereas the first one, you can see both of those objects in the same field of view. And if you have multiple objects, like the moon going in front of the Pleiades, or planets going, like one time Mars went between the Hades and the Pleiades. You know, having binoculars, you can track them as they go through those fields of view.
And those objects you mentioned, are those star clusters?
Binoculars show star clusters a lot better than telescopes do. And that's because a lot of the open star clusters are so large, like the Hades, the Pleiades, the Perseus A cluster. They're so large that you just can't see the whole thing in a telescopic field of view.
Well, okay, you mentioned watching your children play sports. So if you have a pair of binoculars at home that you would take to a football game, or maybe take out to look at birds in their natural habitat, you could also use those for astronomy as well?
That's exactly correct. You know, and a lot of people do have binoculars around that they could go outside and look at the night sky with.
Interesting. What's next?
Okay, these are 8 by 40 binoculars. So when I'm talking about the numbers, 8 is the power, so it's 8 times power, 40 millimeters is the aperture, and these binoculars have a 9.5 degree field of view. So these are all called ultra-wide binoculars. So like I said, these are my favorite binoculars, and like this you can see Mel 11 or Melote 111, which is in Coma Bersinese. It's also called the Hera Coma Bersinese, or it was the old tail of Leo the lion when that was part of the constellation Leo.
All right.
You can also look at the Beehive cluster and the Murphac cluster with this pair.
Again, because of the wide field of view, it allows you to take in a larger part of the sky and see more.
That's correct.
Very interesting.
Okay, now these other binoculars, these are kind of interesting. These are 10 by 25 binoculars, and they probably have about a 5 degree field of view. But these are called Poro prism because they're straight. They don't have the BAK prisms which angle them out to get them back, the light back to your eye.
Well, there are two different styles of binoculars. You have Poro prism, and what's the other one?
It's BAK 4 or 7. They're prism type binoculars. And Steve, you're holding another type of binocular up here as well.
Sure, these are also low power. These are 7 by 20, so the aperture is only 20 millimeters. In fact, many people get these backwards. I think you look at them this way. You actually look at them this way. I like these small binoculars because they are very portable. They're extremely portable. They fit in my pocket.
And they fit in my pocket too.
And so when I'm out, one time I was driving, I knew that there was going to be an eclipse of the moon, but I wasn't going to get home in time to see this eclipse of the moon. But I had in my jacket pocket, I had a pair of these binoculars, and so I was able to just pull over to the side of the road, and my son and I got to see the lunar eclipse, so the Earth's shadow is going across the moon, in better detail than we'd be able to see it naked eye. And so it was great. There's almost no excuse not to have them in your pocket, so they're always there. They're accessible almost all of the time.
Well, you know, this is very interesting, guys, and we've got an excellent start on our selection of binoculars. What we're going to do, though, right now is take a quick break and show everybody our public service announcement, which I'm sure they'll find very interesting. We'll be right back. Welcome back to our show. In the first part, we talked about binoculars that have a wide field of view where you can see a large expanse of sky. In this next segment, we're going to talk about mid-range binoculars. Those binoculars that will magnify an object a bit more, make it seem a bit larger, but you'll also have a smaller area of sky. So Ken, in this next group, what binoculars do we have here?
Well, in this group here, We have binoculars that you're more likely to find around your house because you might have them for other reasons. And these are the more common ones that you'd find in the stores. Now this one just so happens to be 10 by 50 5.5 degree binoculars, and these were discovered in somebody's house. So these are just ones that you'd have lying around the house. These ones are 10 by 50 7 degree field of view binoculars, and with any of these binoculars, things that you'd be looking at, you can see smaller clusters, the open star clusters. The two of the more common ones that you'd see would be M45 Beehive cluster and M45 Pleiades, and those are some of the objects on the Messier object list. And the M45, if you look at it with the naked eye, it looks like a little mini dipper. Some people do get confused and think that it is the Little Dipper, but when you look at it with binoculars, you can see many more stars in there. And in Beehive, if you're in a very dark location, you can see the glow of the Beehive, which is also called the Praecipe, in the sky. And when you look at that, which is about halfway between Pollux and Regulus, Cancer is a very dim constellation, so I normally go off of those brighter stars and look halfway and scan the sky, and I can see it very easily.
Well, Ken, I noticed when you were talking about these first two sets of binoculars, you mentioned them as being the same size. Now, to me, though, this first set appears to be much older looking, where this one looks like you would have bought it yesterday. Does the age of a set of binoculars have any bearing on what you can see?
The only difference between the age of binoculars, if they're both in good culmination, is newer binoculars might have better coatings on them, but basically the optics are all the same.
I see. And collimation would be how well or poorly the optics are aligned in the instrument?
Right, because the older binoculars are, they might have been banged around and they might have come out of culmination. So when you're focusing with binoculars, you hold off to your head, and then you'd move them in and out to make sure that your eye distance is aligned, and then you would focus on the center part, which you focus with the left eye, and then you just fine-tune it with the right eye to get the right eye, because both eyes normally aren't the same.
Oh, I see. Okay. You have separate focus for each eye.
Right.
All right. Well, which one next are we going to talk about?
Okay. This one is moving up in power. So these are 12 by 50 binoculars. So 12 power is pretty high. So when you're looking at this one, I was pretty impressed by looking at M13 Hercules. Now you can start to go into the globular star clusters, which are a lot more compact. Their star clusters are held together more by their own gravity than the open star clusters, which every once in a while a star bounces out and it gets lost from the cluster.
So the globular cluster would be more circular, round shaped, like a ball.
Correct. And also with this, you can start seeing the Andromeda galaxy a lot better. You can start looking at galaxies as well. So these were 12 by 50s, and these had a 5.5 degree field of view.
I noticed too, when you're going up in magnification, in power, the field of view gets smaller and smaller.
Yeah, that's a limit of optics. You can't have both high power and wide field of view. And as we mentioned at the beginning, in a telescope, you rarely ever get anything wider than a degree and a half, 2 degrees field of view. So all these binoculars, so far every one of these had much wider field of views. Now with binoculars, you can tilt them up at the sky, but you do have, neck constraints.
Mm-hmm.
How high you can tilt it up. But when you have lighter weight binoculars like these, I like to lie down on the ground and just look up in the sky, or you get a lawn chair and you can look up in the sky. And you have a very unique way of mounting the binoculars here.
Yeah, that's right.
Keeping them steadier.
So I have a pair of binoculars. These are 10 by 50, much like this older pair and this newer pair. These were extremely cheap binoculars. One of the local sporting goods stores had them on sale for $25. Brand new binoculars. They're in great collimation, that is, they're aligned. When you look at a star, you see one star, not two. So I have them mounted on a photography tripod. This is not a cheap tripod. So we have $25 binoculars. We have a $250 tripod. And then we have an adapter here, and we can sort of show the adapter. The adapter screws into, using a standard screw, into any binoculars. Certainly this one has a cap, and you pop the cap off and you screw them in. This little tripod adapter was maybe $14. It wasn't extraordinarily expensive. So I like using them on a tripod because the tripod holds them very steady. And if they're steady, then the object isn't sort of dancing around in the sky. You point the binoculars at the object you want to see. You look at it, it's steady. You can walk away from it and have somebody else look at the object that you found. If you're hand holding a pair of binoculars, you can hand them to somebody else, but they then have to find the same object that you found.
I see. And this would help for larger binoculars then that would be too heavy to hold up with your hands for a period of time.
Absolutely. There is a problem, which is like hand holding. If you're looking too high in the sky, it's very difficult. I find that up above maybe 45 degrees, my neck starts to hurt, and you know, as if I'm hand holding them. It's not really different for that.
I see. So to go higher than 45 degrees, it would be a good idea to perhaps have a blanket on the ground or a chaise lounge that you can recline in?
That's right. And I take the binoculars right off the mount and just do it.
I can get up to about 60, 65 degrees before I start having neck problems looking up at the sky. So the next we did talk about power and handheld binoculars, and a lot of the books they recommend 70 by 50 power binoculars as being the most useful binoculars. Now these ones are 9 by 63, and these have a 5-degree field of view. So these are the highest power that I recommend using with the hand. And you know, you can look at brighter objects. And these binoculars over here, these are 25 by 100 binoculars. So that means 25 power, 100 millimeter aperture, 3.5-degree field of view. And I had the most spectacular view of Andromeda up on the top of Mauna Kea, where it actually filled up 2 fields of view.
Well, you know, Ken, that sounds like an exciting story, and we do want to hear it, but we do have to take this break to show you some upcoming astronomy events in our area. In our last segment, we just started to talk about this pair of binoculars right here and the great observing experience you had with them in Hawaii. Ken, please continue your story.
Yes, as I mentioned, binoculars are very portable, and I couldn't take my large telescopes with me to Hawaii, but I sure could take these 25 by 100 binoculars with me to Hawaii. They do mount on a tripod, and I wouldn't be using these if they weren't mounted on a tripod. Unlike the other binoculars over there, these ones have a mount feature that comes already with the binoculars, so you don't have to buy anything extra.
So these would be way too heavy to hold up with your hands and observe?
I did try holding them up once to look at North American nebula, but I was lying down on my back and almost got 2 black eyes. So I don't recommend that. But You know, here you can see Saturn, you can see its rings. It's pretty small at 25 power. You can see the moons of Jupiter, but if you have those planets in front of the Beehive or in front of the Pleiades, it's pretty awesome. And also if you have the moon passing in front of the Beehive or the Pleiades, I prefer this over the telescopes. And these binoculars, as I mentioned, the 9x63s, you know, I could lie down on my back and look straight up at the sky and see these. So these are very useful too.
Well, Ken, you know, this has been a great discussion, and Steve as well, about the various types of binoculars, the styles, the sizes, and what you're able to see with them. This has been a great discussion, and I'm sure our audience is going to learn a lot from this. Right now, though, we're going to move over to our last segment of the evening. It's What's Up in the Night Sky? The things that you can actually see if you went outside to look with your eyes, or even a pair of binoculars. And to bring this segment to you, we have the Ford Amateur Astronomy Club's Steve Whitty. Steve?
Hi. So this is the What's Up for mid-June, mid-July 2009. We're coming up on the summer solstice. The 21st of June is the longest day, which means that it's also the shortest night. The sun doesn't set until 9 p.m., so you know your little kids are already in bed probably by the time you get to sunset. And astronomical night doesn't start until a couple hours later, 11 o'clock. So the really dark part of the night lasts from maybe 11 until 2, so you only have about 3 hours to do any really serious observing. The evening planets, Ceres is in Leo in the west at sunset. The rings are nearly edge-on. So when the rings are edge-on, that's the time when you can see planets, you can see the moons of Saturn the easiest, and that's because you have the least amount of glare from the rings. Also in Leo, we have the dwarf planet Ceres. Ceres started as a planet in 1800, was demoted to a minor planet in 1850, there and abouts, where it remained until recently when Pluto got demoted from a planet to a dwarf planet. Ceres got promoted to a dwarf planet. And so Ceres is in Leo, Saturn and Ceres set around midnight. All of the other planets are morning planets, starting from the sun and working farther from the sun, that is hardest to easiest. Mercury was just recently, on the 13th, was at greatest elongation, and that means that it was the highest in the sky, that is the farthest away from the sun, so maybe a half an hour before sunset, which is 4:30 in the morning. Sunset is like 5 in the morning already. Sunrise is at 5 in the morning already. So at maybe 4:30 in the morning, you look for Mercury. You've got to have a really good eastern horizon to get a good chance to see Mercury. Higher up, and this is about 2 hands higher, so you've got a hand and then maybe a hand higher from the horizon. You have 2 planets, very bright Venus, and dimmer and much redder, of course, Mars. You can use Venus to find Mars. Both are naked eye. Again, that's in the east, a couple hands above the horizon. Uranus is about 3 hands, or maybe 3.5 hands above the horizon, also in the east, but it is not a naked eye object. You'll need at least binoculars in order to see it, and you'll need a good sky chart to find it. Also about 3.5 hands, so it's the same height as Uranus. Jupiter and Neptune are that same height, but they're not really in the east, they're in the south. So, turn right to the south to catch Jupiter and Neptune. Jupiter is naked eye. If you want to find Neptune, which you might be able to find in a decent pair of binoculars, you may be able to use Jupiter to spot it. They're about a degree apart, so they're maybe a thumb or so width apart, but if you're going to be needing binoculars at least in order to see Neptune. So that leaves us with the moon. The moon phases are on Tuesdays. starting about now. June 22nd, the moon is new. You're not really going to be able to see it. It's going to be lost in the glare of the sun for the most part. First quarter, June 29th, the full moon is on July 7th, so just after the 4th festivities. The moon is going to be out all night when it's full. And then last quarter is July 15th, which is a Wednesday, but Tuesday more or less. So that's pretty much it for the easy objects to see where the planets are in the night sky in June and July.
And I'd just like to make a comment. You did mention the asteroid or the dwarf planet series, but with binoculars, it's very easy to find asteroid Vesta and Sirius because of the wide field of view that you have, and all you need is either a star chart that has it plotted out off of your computer or one of the magazines, and you have more